Hi everyone. Good morning. Hope I'm audible. Visible. Can you hear me? We'll do a quick audio check.
Yes.
Okay, great.
Go.
Okay. So we'll wait for 3-4 minutes. Okay. We'll start at 8:05 for more folks to join me. It's the first day and pretty early morning. Just wait for a couple of more minutes to start. So share my screen parallelly. Uh, so yeah, I think we can start. It's already 8:05. Okay. So yeah, very good morning to everyone who have joined. So this is the deep learning and AI subtopic of this ML course, right? Just wanted to understand before we start from all of you, like, have you done the classical ML course? Like, are you aware of basic terminology like classification, clustering, regression, and these things? Like anyone who is not aware or anyone who wants a quick refresher on those, so we can plan it accordingly. That's why I wanted to know from all of you. Okay, great. I see two yeses in the group itself, in the chat. So I am hoping like all of you have done the basic course, are aware of the basic ideas, basic knowledge around machine learning, like the what's of machine learning, right? So this specific section, the next 3-4 weeks that we'll go forward, we'll talk about in depth in terms of deep learning, right? Which is an upcoming field in the area of AI, right? So deep learning essentially talks about non-linear models. How do models interact? In a model, how does features interact with each other, and therefore create a model which is much more powerful, which is much more dense, which understands much more intricate or hidden features in the data, hidden patterns in the data, right? That normal models are not capable of dealing with, right? So that is what we will learn in the next set of classes. Okay. So ideally, we will break down this discussion into two major subtopics. Okay. In chat. Yeah. Okay. And parallelly, we will also do a bit of doubt clearing. Like I think already Kiran has posted in the group that to talk about a bit of time-based classification. So we'll do those also, right? So we'll keep maybe the Fridays or like whenever we come to that aspect of thing in deep learning, we'll talk about the basic approach first, and then we will look at the AI side of things. Okay. So ideally, artificial intelligence is essentially what it has tried to do over the last few years is to mimic the human brain very nicely, right? And when we say mimicking the human brain, it would mean that understanding how in a human body, how in a human mind, how people learn, right? So we learn through iteration, we learn through first we try to predict something. Okay, when we see a face we try to remember, okay, where we had seen that face before, right? Or we try to remember uh, that if in my memory if I have a name associated to that face, right? Also we will try to think of, okay, if I've not seen that face, okay, somebody similar that I have seen, I'll automatically my cognitive memory or my subconscious will try to remember that person's name who looks similar to the person, right? So all these types of things we try to mimic in the field of artificial intelligence, in the field of deep learning. Okay. So we'll first talk about what all we will learn about in this course, right? And then we will go into depth. By then, more people will also join in. So today, being the first class, we'll keep it light. We'll talk about what all we want to do, and we'll try to form a framework like, okay, this is what we'll look at. This is the code side of things that we'll look at. For this, we need to install this XYZ kind of things, right? And this is what we want to talk about. Okay. So I will use my this OneNote as a whiteboard for our discussion. So I have a stylus here. So when I write on it, it becomes very difficult to see my video. So I'll keep the video off. Okay. And again, because I'm sharing screen for some of you, there might be bandwidth issues as well. So I'll try to keep the video off when I work on the notebook. Okay. So every day, the first 5-10 minutes, I'll keep the video on. Then we'll switch to the blackboard, to the whiteboard where I write things up or where I show code, right? And there I'll try to keep the video up because I also want your attention to be on the whiteboard. I want your attention to be on the code. And lastly, obviously, I don't want the bandwidth to get impacted due to like two things being streamed. Obviously, somewhere the internet issues and these kinds of things will come up, right? So that is how the mode we will try to keep. So I hope my OneNote screen is visible to everyone, right? So you can quickly confirm. Yeah,
Yes.
I can see a yes. Great. Okay, awesome. So what we will learn first of all, right? So we will majorly learn in this domain about deep learning. So what is deep learning? If we go into depth of it, we will see that they are nothing but neural networks. And because they are not the actual neural network in the brain or the actual neural network of the human body, it is more about mimicking the functionality of how a human neural central nervous system works, right? So that's why we will call it the artificial neural networks that we'll read about. Okay. Then we'll read about a couple of different types of neural networks, right? So different types of neural networks, meaning so neural networks are generally sequential. That is, either we'll move forward or we will move backward. I'll explain the concepts later. But for now, just know that artificial neural networks are generally like either you move forward or you move backward kind of networks. Okay, they're very simple to implement. They're very simple to use. And that's why they have some limitations in how when we process complex data meaning large amounts of text or large amounts of pixels like say images, right? So that's where we come up with different types of neural networks that we look at. So we for images we generally look at convolutions, right? So this is mainly used for image processing. Okay. And the other module that we look at is generally text data. So nowadays if you know that if you have even opened a social media platform or you have even looked at any newspapers, lot of buzz going around with ChatGPT, right? Lot of buzz going around with LLMs, that is large language models, small language models like Phi, Llama that Facebook is building, ChatGPT where Microsoft has a significant uh, investment, right? So these types of companies, what they're doing is they're taking large amounts of data and then they are trying to build models on top of that, right? So we learned first the basics of such type of models, which are known as recurrent neural networks, okay, or also known as RNNs in short. right? So these are majorly used for summarizing text or to predict textual data. Okay. So we'll look at recurrent neural networks in a bit detail. And the other part that we will look at are uh, the actual uh, ChatGPT based algorithms, right? Attention and transformers. We might have heard about these kinds of topics. So basically, where large language models are not directly using a neural network, but they're using a framework of neural networks, which they call as transformers. So we will look at transformers. We will look at transformers. We'll look at autoencoders. Okay, these types of things we'll be looking at, right? Uh, so this is the deep learning part that we will look at. So this generally, ideally, should take around 2.5 to 3 weeks kind of time. Then we will be looking at the natural language processing side of things, where we will be looking at textual data in bit more detail. So before we go into recurrent neural networks and transformers, we'll look at basics of textual data, right? So when you get a text data, how do you process it? How do you clean it? How do you store it? Right? How do you actually figure out entities from it? Right? So entities meaning what is the noun in the sentence? What is the verb in the sentence, right? If I am seeing a complex sentence, like say, Raj loves to play football because it is fun, right? So when I say Raj likes to play football, so it is two parts. So one part is Raj likes to play football. The second part is it is fun, right? So the machine has to understand what does it mean here, right? Right? What does it mean here? So either does it mean football or does it mean Raj, right? So if I had said Raj loves to play football because he is fun, right? Then I would have meant that Raj is a fun person to be with, and that's why he loves to play football or watch football, whatever, right? But when I say it means the football, right? So it can be a even more complex, it can be even more complex sentence. It can be, say, Raj likes to play football in the rain because it is fun. Now, are we talking about the rain that is fun? Or are we talking about the football that is fun? Or are we talking about playing in the rain that is fun? Right? So you can see that there are more and more complexities as we write more complex sentences. Right? So those kinds of things can be to understand those entities. We talk about the natural language processing. So how do we process natural language? How do we store and process natural language? Right? So this is the second part of the curriculum that we'll look at. Natural language processing. So here we would be again looking at cleaning textual data. Okay. We will also be looking at, like we discussed, like entity extraction, like figuring out what entities we are talking about. Okay. We will be talking about information retrieval, right? Information retrieval meaning I have a lot of data. I have a, say, a newspaper. Now I want to summarize it, right? Or if I have, say, two mails, one mail is a spam mail, one mail is not a spam mail, or one mail has a meeting invite, I want to separate them out, right? The meeting invite mail should be added to the calendar, right? So that kind of work is known as information retrieval. So we'll try to retrieve information from the system. Like we discussed, information retrieval can be of multiple types. So one can be, an example can be spam classification. right? The other can be something like extract topics or topic summarization. Okay. The other from information retrieval we can also get is something like a sentiment analysis, right? We can try to understand sentiment, we can try to understand the mood of the user, right? We can try to summarize based on sentiment. Okay. So these are the major things that we can think around in terms of processing natural language. Okay. So these are the two major things that we will understand in this course. So first is, as I mentioned, is the deep learning part where we talk about neural networks, why we came up, the philosophy behind why we came up with an artificial neural network algorithm, right, that mimics the human brain and the central nervous system. Then we talk about different types of neural networks used for different types of problems. So normal neural networks can be used for basic problems like, say, numerical classification, like things that you have already read about, like say SVMs or naive Bayes algorithm or decision trees, right? Or logistic regression. These are all classification algorithms, or say for directly prediction, like say linear regression. So for all these things, we should be able to use a simple uh, artificial neural network model as a replacement. Okay. For more complex data, like say for images, we will look at convolutional neural networks. For textual data, we would be looking at for textual data, we would be looking at recurrent neural networks, right? But even before we go into the recurrent neural networks, we talk about the basics of natural language processing. That is, when we get a text data, what all we can do to analyze the data, what all we can do to segregate entities from that data, what we can do to find out what are the top topics or what are the top summaries, right? Summarization of the data points. What are the top sentiments or what are the top issues that people are talking about, right? So all these things come into play when we talk about recurrent neural network and natural language processing. Okay. And then finally, we talk about transformers. Transformers are the basis of, or autoencoders that are the basis of large language models. So large language models essentially help us in creating, in generating human-like text, textual responses. So anything like a chatbot, anything like a video bot, right? All these things we can use a large language model for that, right? So if you can relate, so the newest examples will be something like ChatGPT, where you give a question, it's a chatbot, it searches the whole internet and tries to give you a human human like text generation, human like answer generation, right? So an even more optimization or an even more higher feature on top of that is like something like say video generation, like say Soro, right? So Soro is the new video generation tool that has come up, right? So that is from ChatGPT that has come up. So Sora is used for like how ads will be made, how movies will be made by giving a textual input to it, right? So that is what Sora is doing currently. So that is all that comes through the transformers and autoencoders. So here, if I have to add examples, so we'll talk about LLMs, like say ChatGPT, an example. So this is a large language model. Then there is a text to video model that we talk about. So we have text to video, where we'll talk about Sora. Okay. There is also another thing called small language model. So if we have time, we'll also cover this. So small language model, there is something called Phi. So which is a small language model that will work with. So even with small data sets, how we can create a model, that is what we will look at. Okay. So yeah, this is the basis of the course. Now, okay, I'll pause. Briefly pause here. We've been into this like for the last 15, 20 minutes. So any questions, anything on your mind before we go to the next part? Anyone? Okay, so we'll keep it like this. So you can just unmute and ask. If you don't want to unmute, you can just put it in the chat. I'll take up questions from the chat and we'll be discussing. Okay. So I think one question is, will we be doing coding along with the concept? Yes. Because this is like we want everyone to be prepared for the industry, we will be doing coding, right? I'll come to the code aspects after this. I'll talk about the languages. I'll talk about the frameworks that we want to code on and all these things. Okay. Any other questions? Yes, so Vatsala has asked any projects on this concepts or yeah, projects to showcase in the resume. Yes, so we will be doing projects, right? We'll be doing small projects as well as we'll be doing some large projects. Okay, so small projects will be very simpler projects, like we'll take up some textual data from the internet and we'll be trying to clean it up, right? With the frameworks that we'll look at, we'll try to understand, okay, what what are the entities, right? What is the noun? What is the verb? What is the subject? What is the predicate? All these things, and right. So that is one part. The other part is the large projects that we'll look at. Large projects will mean like we'll take say a big text data. We'll try to build an encoding machine learning pipeline on top of that, right? And these kinds of things we'll be trying to do. Okay, so let's talk quickly about the projects, like what type of projects we'll look at, and then we'll come to the frameworks. And I think there are multiple questions on the frameworks and the languages, so I'll take that up also, right? So project wise, for the NLP side of things, so I'll just add here only. Okay, let me just see if I have space here. Yeah. So for the deep learning side of things, the projects that we'll be majorly looking at will be something like uh, for CNNs, we'll be looking at because it is image processing, right? So we'll try to detect whether the image of an animal, like if I have an animal photo, we'll try to detect which animal photo is it based on some data set, right? Or some kind of a facial detection algorithm. So both the algorithms have the same basis, that is, we will be using CNNs for that. So we will talk about face, animal, or object detection. Okay, object meaning like whether the image is of a cat or versus it's a shoe or it's versus a hat kind of thing, right? So this kind of a detection we will look at for the CNN parts. So this is a big project that we'll do. For recurrent neural networks, we'll be looking at some type of summarization. Okay, so we'll take some new newspaper article and then we will try to summarize it. So say newspaper text summarization, and it doesn't have to be like it doesn't have to be just a newspaper article, right? It can be any article per se. It can be a research paper, it can be a website, right? Anything we will it can be summarized, right? So we'll try to summarize that article. Okay, edit summarization, right? For transformers, as I mentioned, so we'll be using LLMs directly. We'll not be creating LLMs per se, because LLMs creation, because we need a huge amount of data set for even creating small language models. So that is not feasible to do it on a local machine, and there is no use case for doing that. Generally, LLMs will be built by large corporations and we'll be trying to tune it to the usage, to our usage. So we'll be looking at ChatGPT and fine tuning. Okay, how to tune them to our requirement. So we'll be looking at tuning of LLMs as projects. Okay. For natural language processing, we will be looking at any type of data that we need to clean. So generally, Twitter data is very dirty because there are a lot of smileys, there are a lot of short forms, right? So we'll try to clean a bit of social media data. Okay. We will also try to pre-process data a bit. So like we talked about, so spam classification, we can build a spam filtering model. Okay. We would want to build something like, uh, say, in sentiment analysis, we can build maybe around, say, restaurant food reviews or movie reviews, right? So I'll just call it review analysis. We'll see when we come to that, like whichever data set is available online, we'll just take it and try to build it on top of that. So we'll call it reviews analysis. Okay. And then topic summarization is like we have, say, thousands of feedbacks, and this I'll show on actual real world data. So if we have thousands of feedbacks of a particular app, say I'm giving an example, say Microsoft Word, right? So there will be lots of users, millions of users around the globe. So you can't be looking at each feedback and you cannot be building on top of that, right? So basically, how do we actually generate topics from that, right? How do we actually say the top issues or the top topics that people are facing, right, in Microsoft Word, right? So that is what we will try to look at. So look at customer feedback, topic modeling. Okay, so we'll try to do customer feedback topic modeling on top of that data. Right, so these are the generally the small projects that we'll do. So we'll do it, say, we'll take up two use cases, two or whatever we learn in the week. We'll take up those and we'll try to implement them and try to see. So we'll do it, say, in every day in the class only. We'll try to do a concept, and then if we'll try to implement a data set, we'll try to look it up, right, and we'll try to build it up. So this is the first set of questions that you had around the projects. Right. The second part is around the frameworks and what we will be learning, right? So ideally, the prerequisite for this course is that you should be able to understand Python, right, as a programming language. So all of you are well versed with Python, more or less, or do you need me to talk about Python also a bit before we go into the details?
Uh, uh,
Everyone,
it,
yeah.
it, it will be good if we just get the Python required for this thing.
Okay, okay, cool. So we'll try to do that. Give me 1 second. There's someone at the door. Yeah, so we will do the Python required for this course a bit. Like we'll talk about what are vectors, right? How do we use them in what are data frames? So very basics of pandas, right? Very basics of NumPy, but we'll not go into depths of NumPy and pandas, right? While we work on that, we'll see whatever is needed. We'll use that accordingly, right? So that is what we will look at a bit. So we'll not go into depth of like how to manipulate data frames or all these things. So whenever whatever we need, we'll try to write code, and then if there are any errors, I'll try to discuss what the errors are, right? Why will you will face such errors, and also like whatever is needed, we'll pick up accordingly. So we'll have and that's basics. And from a framework perspective, we will look at majorly TensorFlow, right? So we'll be looking majorly at TensorFlow. So TensorFlow is a very, very important deep learning framework that was created by Google Brain around some 8, 10 years back, right? And after that, with a lot of advent of data, TensorFlow has become the go-to language of choice for deep learning projects. So TensorFlow is an important framework that we'll be looking at. In terms of APIs, we'll be looking at two very important APIs. One is Keras. So Keras is an API that we will be using very frequently, right? So Keras was initially created as a standalone API, but now it has been incorporated into the TensorFlow altogether, right? So Keras we will be looking at as a part of the TensorFlow, okay? And so Keras and TensorFlow majorly is what we will be looking to work with. So we'll also be looking at another framework. So the other API that is known as PyTorch. So PyTorch is basically an implementation of Python that will be used for the deep learning aspects. Okay, so we'll also be looking at PyTorch in a bit more detail. So let's write that also. Shoot, pen. So let's add the PyTorch framework. So PyTorch will be majorly a framework, and within PyTorch, you will see a lot of APIs that will be there that we'll talk about. Especially, we'll be talking about the Torch API, right? The Torch script APIs we'll be looking at. We'll be looking at the Torch serve APIs for deployment. We'll not go into deployment in detail because like that will come into ML ops and you will not be using that much, right? I'll just touch upon that. And then there is a C++ library also for PyTorch. Like if you want to integrate PyTorch models into C++ applications, then we'll also talk about libtorch a bit. Okay. So these are the libraries that are present in PyTorch. So I'll just put things down. So there is Torch that we talk about. There is libtorch. Okay. We'll talk about for deployments. We'll be looking at Torch serve and Torch script. Right? So this is majorly what we'll be looking at from a framework and APIs perspective. Okay. And obviously the language, we'll be talking about a bit of basics of NumPy and pandas. Whatever is required in this course, we'll be covering those things. Right. I think, yeah, this answers the second set of questions uh, in terms of like building the framework and these things for the deep learning aspects, right? For the LLM aspects, we will be looking at like we'll be taking say ChatGPT 3, 3.5 APIs, right? But we'll not have a API key, so that's not publicly available. So I'll just show internal calls that are there that you can use directly. Okay, it is just an API call. So if you buy if you purchase a ChatGPT plan, you can always use that key to make an API call, right? So an API call essentially It's a wrapped Ajax call or a wrapped HTTP call that you can make from any product, any project, right? So from Python, you can use the HTTP client or HTTP majorly HTTP client only, or Ajax to directly make that API call. Okay, with the API key that you get once you purchase a ChatGPT plan. So I'll just show you how to do it. But we'll not be working much on that. We'll be looking at ChatGPT directly from the interface, directly from the playground, right? Which gives us more flexibility. And reason being, the APIs again have a token limit, so you cannot pass like unlimited data there, right? So say if I have 10,000 feedbacks, right? So I cannot pass all the 10,000 feedbacks to ChatGPT saying that, okay, summarize this, right? So you can maybe pass only 2,000 tokens. So what we do is we first do a classic clustering model on top of the 10,000 feedbacks. So we'll look at how to do that. The clustering model we'll try to build. And from that 10,000, we'll get maybe 100 feedbacks. Okay. 100 unique feedbacks, which belong to different clusters as much as possible. And then those 100 feedbacks will be passing to the ChatGPT layer. Okay. To the ChatGPT API. So that will essentially help us understand that, okay, how, if there is large data, how we can use the LLMs or how we can use the GPT APIs there, right? So you cannot use them directly as is. So we'll be looking at a bit of ChatGPT API calls. Okay. So yeah, any other questions? Deployment in cloud is not part of this course. Okay, so there is a question. There are two questions in terms of deployment. So deployment generally comes into MLOps. For deployment, you have to have a Azure or a AWS server, right? So deployment will happen either in Azure ML or in say AWS SageMaker, right, where you deploy the models. And once you deploy the model, you have to have an endpoint, right, where you will be hitting, say you will be putting the input and you will get back the output from the deployed model, right? So for doing this, then you have to build the front end in terms of the client. You have to host a service, right, where the model will be deployed. So this has a lot of additional work. So we'll see if time permits at the end, then we'll go into the ops side of things, right? We'll look at the DevOps or we'll look at the deployment side of models, but that is not typically part of this curriculum of the deep learning course. Okay. We'll see if we have time towards the end. If we have like if we find a good use case for that, we'll definitely do that, right? So any other questions in terms of the course itself? So deployment, I'm not putting it down because it completely depends on how much time we get, right? How much time is there towards the end, and like what are the use cases it solves. If it is there, we'll definitely do that, right? Deployment again, I generally prefer to do it in Azure ML because like I have a free license. For you can what you can do is you can take a 30-day free trial towards the end of this course. I'll let you know if we have time. We'll try to take a free trial kind of thing, right? And we'll try to use that for deployment. We'll try to do it in Azure only, but similar
Azure,
things can be done in AWS SageMaker also. I think I heard some noise. Someone saying something. Okay. So Azure license cost, there is a question. So license cost, I'm not sure. So it depends on the type of license that you have. So you can have, I think, a basic or an enterprise license, right? So you can look at azure.microsoft.com and take a look at the license prices. But the good part is like you can take a free trial kind of thing for 30 days to evaluate, right? So in that 30 days, we'll try to create an ML model kind of thing. Like if we get time, we'll try to do that. We'll try to deploy it. So in that way, like you will not be paying extra money to Azure just for trying things out, right? So that's what we will try to do. Okay. So any other questions regarding to the syllabus itself, regarding to the curriculum itself? I'm just putting it in full screen. So whatever we have discussed today till now, because I see more people have joined in. So that's great. So we talked about the we'll talk about deep learning in bit more detail. So we'll start with neural networks today, right? And as we go forward this week, we'll try to cover a bit of CNNs, a bit of image processing. Next week we'll look at textual data and NLP, and then RNNs, and finally we'll talk about transformers.
Can you give me a bit of history of ANN?
Yes, we'll talk about it. Yeah. So let's go into the details of the course. We'll talk about a bit of history, how we came up with this, right, and where we are now. So yeah, let's start then. I'm just pulling up the historical side of things to talk about. 1 second. So the rise of deep learning essentially happened. Just share a snippet from the MIT Open Courseware, okay, which talks about the rise of deep learning. Let me reshare my screen. Yeah. So this is a slide deck that was presented in it's a part of a course called MIT Open Courseware, right? Where like the rise of deep learning was explained very nicely, like how it started, how the work all the work started, right? So the earliest work that started was like in 1960s when neural networks were discovered and as a part of the biology, as part of biology and as part of human understanding the human nervous system, right? How the nerves work, right? How do the pain points work and all these things, right? So that was the first like understanding that okay, something like this exists. But then there was neither the data nor the there was neither the data nor the compute to think of translating it to a machine, right? So that a machine can do that, or a machine can learn around it, right? So there was no compute around it. So as more and more data came into the fore and compute became cheaper, that is, machines became of lesser size, right? Chips became much more powerful. Compute became much more easier to access, right? The cloud tech came into play where like didn't have to own or maintain a machine to be able to use it, right? So all these things actually helped the AI cause, right? Actually helped the building of a deep learning or artificial neural network building kind of thing. So what ML scientists or what computer scientists started to work on is like as humans learn, right? As neurons look at like okay, as neurons try to make long-term connections, right? In the brain. So each neuron will pass some signal to the next neuron, right? The next neuron will pass some electrical signal to the next neuron, and so on and so forth. Finally, it reaches the stimuli, right? So what happens is that say you are there is some saucepan is there or some plate is there and you just touch it, okay, and when you the moment you touch it, what happens is say there is some temperature x of that pan, your hand, your finger, the tip of the finger touches it, right? The moment the fit of the tip of the finger has touched the pan, you understand that it's hot, right? So how do you understand? So you touch it, so the neurons at the tip of the finger understand the temperature difference, right, and communicates it back to the brain, right? So this is known as a feedback loop. So it has communicated back to the brain saying that, okay, there is a high temperature difference in the, so the pan is at a higher temperature than your hand, right? And if you continue to touch it, then you will get burnt, right? And it knows from previous experience that burning is not a good sensation, right? There are other side effects of burning, like it will cause pain, you might need medication. So all these are stored in the subconscious, right? So now when you have touched it, so the brain will immediately send signals back to the tip of the finger saying that you have to now remove it, right? As soon as you can. And this whole chain of electrical impulses happens so fast that we don't even get to think around this kind of complex stimuli that leads to that, right? So this is essentially what a neural network tries to mimic. So we have a set of predetermined or pre-learned models or pre-learned techniques. Okay, and those learnings help us build onto our new learnings. So when we are looking at new data, we'll see from our previous learnings that can we apply anything here, and based on the strong connections that we have developed, we'll try to create a very fast feedback loop kind of thing, right? That will basically tell that whether we are in the right direction or not. Okay, so this is the mimicry of neural networks into the artificial neural network space, right? So Google Brain was the first like company funded AI work that had started, right? So Google Brain essentially was the team behind building the TensorFlow framework, where we can actually create, where we can actually deploy models, not per se with deployment. So deployment happens in the Google Cloud Portal, that is GCP, but the creation of models and understanding how models work, or testing accuracies, all these things, you can do it on Google Brain itself, on TensorFlow itself, right? Then AI was used for uh, a lot of initial use cases, right? So the initial use cases were very basic use cases to understand, say, facial features, to understand objects, right? To understand handwriting, um, uh, trying to convert the OCR based mechanisms that we earlier had. So earlier, if you have done the basic ML course, you might have looked at classification based on the OCR dataset, right? So neural networks were tried to first work on those things, right? So we looked at supervised learning, we looked at unsupervised learning, and we looked at reinforcement learning. So generally, AI has three specific domains on which they work, right? So majorly we look at supervised and reinforcement learning. Unsupervised learning we look at only in terms of textual data, in terms of topic summarization and stuff like that. Okay. So if you see, like, these are like a lot of news articles that are there where neural networks came into the fore, like AI beats dogs in cancer spotting in early patients, right? AI it helps generating a lot of believable fake photos, right? That is the deep fakes that we talk about. Then AlphaZero leads the way for chess computers, right? So AlphaZero was the name of the chess that AI chess machine that was built, and that played actually well against one of the, I think, the Russian champions whom they which they defeated, right, in one of the chess matches. So that is one of the important applications of reinforcement learning that we'll look at later, right? uh, so DeepMind was used, deep voice was used to clone anyone's voice, right? With a little bit of audio, you can just clone anyone's voice. So Baidu had created that in China, right? So this kind of like history AI has, and these are the things that were done, right? So coming back to the course, I'll again open the OneNote once. So yeah, so this is the history, a brief history on in terms of AI. Okay, so I just pulled up the MIT Open Courseware deck to show like the news articles and all these things that I can't write about or can't explain, right? So this were the initial set of things that propelled people towards artificial intelligence and neural networks. Okay, And why did we do deep learning? Why did we need deep learning per se? So majorly for two applications. So one was a classification tasks. Before that were not that great. So if I have to write about it a bit, so why neural networks, right? So neural networks were primarily used essentially because classification tasks were not doing well. Okay. So classification tasks were essentially bottlenecked due to performance issues. Like there was no mathematically, it was not possible to improve the speed of the classification tasks, right? So by maths as well as by hardware. Number two is slowly the advent of a lot of more data, right? So when if you see classification problems, then after say 1 million data points or things like that, there won't be much more additional improvement in the results, right? So the incremental availability of data didn't help in increasing the accuracy of ML models, right? So that was a big problem with classification models. So AI solved that. So neural networks leveraged availability of huge amounts of data. Okay. And the third thing is that neural networks were majorly used for, and then the compute came into play, right? So compute essentially means that like there were parallelizable machines, there were very cheap chips that were available on top of which we could actually create rules, on which we could actually build models. So models at the end of the day are essentially rules, right? So they are and odds or kind of rules that are there, right? But we cannot see that rules. So the models are essentially built to abstract out the rules below, underneath them, right? So that is the third part. So the availability of commodity hardware. So what is commodity hardware? Commodity hardware essentially means the data centers that are there, right? That store a lot of data. So they won't use a lot of very top tier CPUs or top tier machines, right? So whatever are like junk kind of things that are given away, that have been used for 10 years, 12 years, because they are majorly used for storing the data or for doing repetitive tasks. So we don't want very high tech hardware there. So it is known as the commodity hardware. Okay. So a lot of cheap availability of commodity hardware where a lot of data could be stored and a lot of models could be run efficiently. Right. So these are the three major things why neural networks came into the fore. Right. So availability of commodity hardware. Right. So availability of commodity hardware to store and process data. Okay, so these are the three major things why neural networks came into the fore. Okay, and how did neural networks like affect, like how did neural networks build the expertise? So if you look at neurons, so what are neurons? So neurons are essentially look like, so we have perceptron, right? And then there are some input signals that come into play, right? And then there are some output signals that go out, right? And then there are other neurons also, right? So something like this. So these are neurons that are coming out, coming from somewhere, and then they are passing it to, it's a like a, right? they are connected like this, and then they are taking some signals away, right? So it's an interconnection of different nerve endpoints, right? So essentially these are the endpoints, right? And so these are the endpoints here. And if you have to about it, say these are the inputs, right? Some input, something is there, right? And then essentially we have the synapse and the nerve endpoints. So we have the synapse here. So these are also known as neurotransmitters, right? This essentially now for one nerve endpoint. So these are, so I'm not going into the biologies of these, but we have like multiple things like, so these are known as the, this is the endpoint, right? And then there are some axons here, right? Which essentially take the, uh, they are the conductors of the electrical signals that are there, right? And then each nerve will have will each nerve endpoint will have something like a nucleus, right? So this will be known as the nucleus, right? So the human brain consists of neurons or nerve cells which transmit and process the information received from our senses. So these are the senses, which are the inputs. Okay. So many such nerve cells will be arranged together in our brain to form the network of nerves, right? And these nerves will pass the electrical impulses from one neuron to the other, right? So the dendrites that are there, the dendrites will receive the impulse and from the terminal or the synapse of an adjoining neuron. So from this synapse, it will, these dendrites, these are the dendrites, the connections, right? So they will receive impulse from an adjoining neuron, and then they will carry the impulse to the nucleus of the nerve cell. This nucleus, this is also known as the soma, but we'll call it the nucleus only for now. Okay. And then the electrical impulse is processed and then it is passed to the axon, right? So here each will have some axons, something like that, right? It will be passed to the axon, right? So the axon is the longer branch. So what it does is it will carry the impulse from the nucleus to the next synapse, right? And then the synapse will pass it to the dendrites of the second neuron. So like this, the propagation happens, right? So similarly, in a so artificial neural network, what happens is that we have some inputs. Say we have x1 and x2 as the inputs, right? So I'll just have two inputs for now. So what are x1 and x2? X1 and x2 are the features, right? So x1 and x2 are the features. Okay. And then we have two things. We have some weights, that is how big the stimulus is, right? So like if say like I told an example of the holding the saucepan, right? So if the saucepan or the if the plate is very hot, then the impulse will be very fast. The impulse signal magnitude will be very high, right? And we'll remove the hand very fast. If the temperature is not that hot, we will not be removing the hand very fast, right? We'll keep it slow. So that amount of surprise will be much less, right? So that is the weight of the input that we talk about. Okay, that is W1 and W2. So each input will have their weights. right? So weight essentially means the strength of the input. Okay. And then each of the inputs will be assimilated in the neuron, right? So assimilated in the neuron, what it looks like. So if I do an assimilation, obviously the weights will be multiplied by the inputs, right? So the total input will be okay. So the total weight, total input X is given by this, right? And if I had more inputs, then obviously it will be sigma of Wixi kind of thing, right? And then if you think about it, like if I have multiple uh, inputs and outputs like this, let's say this goes to uh, some neuron, and this again goes to this output goes to some other neuron, right? And some other neuron's input comes here, right? Say this is W3 X3 plus W4 X4, right? And this output, again, say this is W5 and this is W6. Okay, so what will be the output of this? Can anyone tell? If I have to directly write the output of this or the assimilation of this will be W6 multiplied by W1 X1 plus W2 X2 plus W5 multiplied by W3 X3 plus W4 X4, right? At this point, this will be the output, right? But right? So then this is also a linear thing only, right? This is essentially what? This is some W6 W1 X1 plus W2 W6 X2 plus W5 W3 X3 plus W4 W5 X4 kind of thing, right? Sorry. So got a bit congested here. I'll just write it in a better way on this side. I'll just write it here. So we have W1 W6 X1 plus W2 W6 X2 plus W3 W5 3 plus W4 W5 X4, which is nothing but if I created a neuron, if I created a node, and if I passed all the four inputs here, right? Say I had X1, I had X2, I had X3, and I had X4, right? And I had given some weights here, say A1, A2, A3, and A4. Then essentially this is my A1, right? This is my A2, this is my A3, and this is my A4, right? So I made a complex multi-layer neural network that boils down to a single perceptron or a single layer neural network, right? So directly joining the outputs to the next inputs doesn't give us any additional value, right? So this is the main point of telling this. So cascading outputs to next set of inputs in a neural network does not add value, right? And why it does not add value? Because it boils down to a linear neural network, right? Does not add extra value. We could prove it by this logic, right? Emphasis on does not, right? And that is why what do we do is at the node, right? At the neuron, at the node level, we'll try to add some non-linearity, right? The solution is add non-linearity. So how do we add non-linearity? So we have a linear value, right? So we have the input as w1 x1 plus w2 x2. So how do we add a non-linearity here? So we can say that non-linearity will be, say, f of x, which would mean non-linearities can look like many different things. Okay, so we can have a tanh non-linearity, or we can have a sigmoid function. Okay, so we can write sigmoid of w1 x1 plus w2 x2, right? So what is a sigmoid function? A sigmoid function is essentially looks like this. Okay, so anything between 0 to zero point 0.5, it will make it to 0, and anything between 0.5 to 1, it will make it 1, kind of thing, right? So this is a sigmoid function. Or we can use something like say a tanh function, right? Tanh function essentially is, again, very similar to a sigmoid function, but that's a nonlinear function that can be used, right? So nonlinear activation. So this is also known as the activation function. So for adding nonlinearity, we call something as a activation function. So what are the different activation functions that we can use? So it is activating the nerve, right? It is activating the nerve endpoint, right? Otherwise, you would have got a singular nerve endpoint, right? So first is sigmoid. I'll write it here, sigmoid. Actually, I'll remove this one. I'll draw it in a bit better way. So sigmoid function looks like, I'll give the math first. So 1 by 1 plus e power minus 1, right? Or e power minus x, sorry, right? So this sigmoid function, if I have to plot, it will look like this. Say this is the 0 line. This is minus 1. Sigmoid doesn't go below the x-axis. This is, say, plus 1, right? So sigmoid will essentially look like this. Okay, this is our 0. This side, this is minus 1. This side, this is plus 1. Right? This is how the sigmoid function looks like. So if you try to plot x, plot this value with y and x, you will see. You can also plot it online, right? You'll be seeing
Hi,
how a sigmoid looks
may I
like.
know your
Yeah,
name, please? Sorry to interrupt.
yeah. I'll come to my introduction. Give me 2 minutes. I'll just complete this.
No,
Okay.
for a sigmoid
Okay.
function, the value ranges between 0 and 1, right?
It is ranging between 0 and 1, right?
But in the figure, I could see it is ranging between -1 and 1, isn't it?
No, the value of y is ranging between 0 to 1. Right? The value of y will
The
always
x
range
value
between 0
between
to 1.
minus infinity
X
to
value is
infinity.
x is independent variable, right?
Yeah, yeah.
So x
Okay.
can go from anywhere to anywhere.
All
X it
right.
is on you, x is on you too, wherever you
Hmm.
can put it, right?
Yeah,
So
yeah.
the activation function, yeah, because this sum that is there, that can be any value. So
Hmm.
x can be anywhere. Your aim as a sigmoid function, your aim is to bring it to between 0 to 1,
Yeah,
right?
yeah, got
And
it.
that's why sigmoid function we also use in logistic regression.
Yeah.
I'm not going in that side, yeah, to make the probabilities, because sigmoid also helps in probabilities. Yeah.
Yeah, fine. Yeah.
Okay.
Yeah.
So yeah, this is the sigmoid function, right? So y will range between 0 to 1, right? And both open bounds, because x, if x is minus infinity, then only it will be 1. If x is plus infinity, then it becomes 0, right? So I'm not going into that part. So this is one thing. And then we have other activation functions also. So we have these are the popular ones. I'll talk about 3. Okay, so we have the hyperbolic tangent, that is the tanh function that we talk about. right? So tan H essentially, if I remember correctly, it looks like this. And just interrupt me if I miss anything. Uh, 6, right? So this is the tan H function, and if I have to plot it again, right? So tan H is essentially, it varies from -1 to +1. So tan H actually cuts the y-axis, cuts the origin at 0, and again the same things apply. So it's bound at -1 to +1. Okay. So these are the two important important activation functions. We talk about two more, but they are not. I'll talk about what the challenges they have later when we actually solve the problems, right? So we talk about a ReLU function, that is rectified linear units. So these are very easy to implement because it just whatever is the function, anything before 0, it makes it to 0, right? Anything negative, it makes it to 0. And anything positive, it keeps the line as is. Okay. So it is given as y equal to max of 0 and x. Okay. So this is what ReLU function looks like. And the other one is known as the leaky ReLU. Why we are calling it ReLU is because RE is there and we take L from here and U from here. Okay. So leaky ReLU essentially looks like this. For negative values, it just adds a bit of some bit of a step function kind of thing, bit of a nonlinearity. Okay, so it's generally a very small constant. So it is given by, I think, theta, not alpha, theta x and x. So whichever is bigger, it will be given by that, and theta will generally lie between 0 to 1. It's a small constant. Okay, so for negative values, this theta x will be bigger than x, so it will become theta x. For positive values, x will be bigger than theta x, so the positive value remains the same. Okay, so these are the four general activation functions that we talk about. Okay, there are others also like exponential, leaky ReLU, and all these things, but we don't generally use them as much. So these four are very highly used, right? So the aim of activation function is to add nonlinearity to our neural network. Okay, and the nonlinearity helps us in building more complex neural networks, as complex as possible, as long as possible, right? So this is what we look at. Okay. There is another term that we talk about in the first layer, in the one layer of the neural network, right? So that is known as the bias. So let's add that. So the bias term that is used, I'll just add the. So just add bias term first, then I'll explain. Okay. So say I had the two inputs only. I had say x1 and I had x2, right, with a w1 and w2, right? So this results in, and then we have a say a sigmoid function that is, I'm just writing f of x here, okay, which is equal to 1 by, so we read about it, so it is about 1 by 1 plus e to the power minus x, right? So if I have to replace okay, so what is the bias first of all? So bias is a constant term, okay, that we add. So say this is a constant term that we add, say this is w0, so there is no input associated with it. Okay, so bias is nothing but a constant term which is added to the product of features and weights. Okay, this is used to offset the result. So this is used to offset the result. Okay, so what does it mean? So it means that it helps the model to shift the activation function towards the positive or the negative side. Okay, so say if I had a sigmoid function, like a normal activation function would look like this, right? It would look like this, right? With bias, the activation function would look a bit different. So it will look something like this. It will be the same sigmoid, so it has to have the same features, but it will be either flatter or, depending on the bias, it can be even be steeper. Obviously, the bounds will be the same. So the bounds cannot change because of the mathematics aspects, right? So it will have a steeper curve. Okay, or it can be even like a flatter curve, something like this, right? So this tweaking happens based on the bias term, right? Because you cannot, so W1 and W2, sorry, X1 and X2 are not in our hands because they are the inputs, right? You cannot change them. But what you can change is the bias term to tune the model a bit, right? So if you increase the bias term, we generally say that the curve shifts to one side. If you decrease it, it shifts to the other side, right? And generally we add biases at every layer of the neural network. Okay, so that like even after adding the activation function, the our like the model maintains nonlinearity, and there is a significant randomization in the sigmoid function. Like we don't want to apply the same sigmoid function at every point, each point of time, right? So the bias also comes as a parameter that we can tweak, that is W0, and that also gets tweaked in the model. So we'll talk about the model tuning and those things tomorrow, but this is what the bias term does. Okay, so it just shifts or offsets the activation function, nothing else. Okay, so we'll talk about it more in more detail tomorrow when we look at like the forward and the backward propagations. Okay, so there are multiple bias terms, multiple biases that we can use. So one is known as like algorithm bias, sample bias, availability bias, exclusion bias kind of thing. Okay, and bias is generally used to like to offset say missing data. So some data might be missing, right? Or some you have taken some kind of sample and that sample is not accurate, right? That sample does not represent the whole data set. So you have introduced a bias, right? So we'll talk about bias and variance in a bit more detail in the next class. Okay, well, we talk about overfitting, underfitting, and these things also, right? So this essentially becomes a single layer perceptron. This is called a single perceptron. Okay, it's a very small
Layers,
neural network.
excuse me, layers in the sense, like, what do you mean? Many layers means the number of nodes you mean to say is layers, or
We'll come to layers. So layers would essentially mean something like this. So a neural network will have many perceptrons, right? So you will have multiple perceptrons like this, right? So these will be, say, your inputs. Say you have 4 inputs, x1, x2, x3, and x4. So the inputs will feed to all the input layers, right? And then there will be hidden layers. So this will be your hidden layer 1, this will be your layer 2, this will be your layer 3, and finally we'll give an output. Output would mean that whether the image was of a cat or dog or not, right? Or whatever the input, whatever the problem you are trying to solve. So I'll talk about interconnections and layers tomorrow in bit more detail, right? So today we learned about a single perceptron, only about this. So this is a single layer neural network because it has only one layer, only inputs, and then it has some output, right? So it's a single layer network with a single perceptron, only one neural network, right? This one you can see it is a 3-layer neural network, right? We'll talk about this more tomorrow. So it's a 3-layer neural network with, I think, how many? 4 into
so
3
why
into
do
4
we have a
connections.
hidden layer? What is the purpose of
So
having?
hidden layers actually help us. We'll come to that. That is what like we'll talk more about. Like what is the benefit of having hidden layers? So give it till tomorrow. Okay. So hidden layers will essentially help us understand. So one layer, what it does is you take an input, you give out the output. Right. You don't do anything else. right? But once you have given out an output, right? So say, so this is the premise to tomorrow's class. Like say, if you have given out the output after so many connections, right? And these are all interconnected. Okay, so if I miss any connection, you can assume that all are interconnected. So this is the final output we are getting, right? So now in a neural network, we actually check like how far our output is from the actual output. Okay, and we propagate the results back. We update these weights back. So each has some weights, right? These arrows, each weight, there's some weights. So W1, W2. Internally also there are some weights, W3, whatever, right? So this W, say X, W20, whatever, right? So this weight will be modified based on how far this output is from the actual output. So this will become W-20. Then we'll come back here. This weight will be updated. So this weight, that is W, say 18, will be updated to how far this output is from the original output. So this will become W18 dash. So we look at forward and backward propagations, and that's where multiple layers are helpful. Okay, so the more the number of layers, generally you'll see better training kind of thing, right? But again, it is like uh, there is some upper limit. Like after that, more layers you add, you will not see better outputs. But generally, you will find a good output when you have more layers, at least more than 1 or 2 layers. Okay, so that we'll talk about that. This I just quickly explained. So these are known as forward and backward propagations. So we'll talk about that in a bit more detail in tomorrow's discussion. Right? Does that answer your question, Deepika, for now?
Yeah.
Okay, cool. So yeah, a bit about myself. So I thought I'll introduce myself in the beginning, but there are very few folks, so I'll talk about it in the end. Because I didn't want to talk about then. So I'm Parijat. So and I have been working at Microsoft for some time now as a DS. Uh, I'm majorly working in the textual domain with like customer verbatims and topic summarization in those. Okay, so we are looking at like large scale. We are building pipelines for large scale verbatim ingestion and trying to understand what are the different drags. Right, drags meaning like okay, if we fix some particular issue, how much reduction in the customer verbatim we will see. That is number one. Number two is how much reduction in the churn we will see based on that. Like people are leaving the business, right? Say after 2 years, somebody is not renewing a subscription. So if we fix an issue, how much reduction in churn or how much increase in revenue we can see. That is the second part, right? And the third part is doing all these things, how we are improving the engagement, right? How we are encouraging more people to use the application. You have different applications like say Word, Excel, PowerPoint, OneNote, Outlook, these kinds of applications, right? So these are the three major things that I'm working on. And yeah, that is a bit about myself. Okay. So yeah, I'll stop sharing. I'll share this doc, like this OneNote with all of you. So I'm currently not added in a WhatsApp group or something with anyone. So if you have any questions, um, feel free to bring up to class tomorrow. Okay, from today's discussion, and we'll continue on the discussion on neural networks. So we talked about a single perceptron today. We'll discuss about hidden layers. We'll talk about neural networks in detail tomorrow, and then we'll look at the programmatical aspects like the TensorFlow, how to install TensorFlow, how to use it, and all these things. Next class. Okay. Cool. So thank you. Any other questions anyone had for me? Questions, concerns, anything?
Okay, so anyway, we can get all these just revised because I was not believing ready for this neural network dose. Yeah. So then any link to just to revise this?
I'll share the OneNote and like this deck itself, and I think the recording will also be made available. There are a lot of resources. I can share some book details. Give me till tomorrow. I'll share the book details by tomorrow. Okay,
Okay, thanks.
like
Thanks.
especially in the deep learning framework, there is a very good book. I'm not sure actually if it is available online, but give me 1 second. I think I have it somewhere with me. Yes, you can actually look at this this website, which has so this used to be a book. Now they have put it in a like chapter wise thing in a website itself, so you can use it directly from here. Okay, so deeplearningbook.org. So there are a lot of there are a lot of details there, right? In terms of linear algebra, the maths aspects, will try to abstract a lot of those. We'll try to make them much more simpler for anyone to read about it, anyone to use it. But yeah, this is a very good universally like acclaimed book that in the domain of deep learning that we can refer later in the course. Okay. And like I talked about the MIT Open Courseware, this thing that is also a very good resource. I'll compile all those together as we go forward, right? As we cover more and more things, I'll share more and more details, like for CNNs, for RNNs, for general neural networks, all these. So we'll put more resources across the board. Does that sound fine? Vikas asked the question, or who asked the question? Okay, cool. So cool. I think we shall. Okay. Cool. Thank you. I think then we'll close today. We start on time tomorrow again, and yeah, we can take it from there. Thank you. Thank you.